Well, hello. My name is David Bodenhammer. I'm Executive Director of the Polis Center, and it's my pleasure to welcome you here to the first of what is a continuing series of, we might call them in the educational world, seminars, called Smart Edge. It's an effort by the Polis Center to bring leading professionals in technology and government and other things to Indianapolis to help us think, both as a center and as a university and as a community, about how it is that technology can inform the work that we do and how we can participate and collaborate together in making sure that we in central Indiana are working as smartly as we possibly can, not simply in one sector, but across sectors. The leading person behind this initiative is our new director of geoinformatics, Dr. Tariq Rashid, who had joined us in, I guess it was March the 1st, right? And has brought a lot of energy to our work, and you're going to be meeting him in a variety of different ways, I'm certain, as he interacts with you. But I'm pleased to turn this microphone now over to Tariq and to ask him to introduce our topic and our speakers. Thank you.
Well, hello everybody. Welcome to the first presentation in our new Smart Edge series of presentation, which we are going to focus on different aspects related to smart living communities. We are focused on the first presentation on the technological take of smart living communities, looking at what is the technology surrounding this, what are the infrastructure technology, what are the barriers and how we can cross the barriers, what's going on, on technology trends. But hopefully we will not only focus on that. Actually, in the future we will try to diversify and bring more speakers to tell us more about the governance of smart technology and the uses, the implication of the social aspect of it. So hopefully that we will try to cover this from different perspectives. We plan to hold this every month at least, and we thankful for our two guest speakers today from Boundless, who are coming all the way from two different places, from North Carolina as well as Egypt, to tell us about things related to how open source GIS is supporting the back end of smart city initiatives in terms of the trends, in terms of the technology. So our actually official title is the evolution of open source GIS and its application for big data analysis in smart cities. We're going to have actually two presentations, each around 30 minutes, followed by some questions, and then we'll have some discussion at the end. Just for the housekeeping, we have the restroom nearby here, and if you can turn off your cell phone, that would be great. And our next speaker is Mr. Anthony Calamito. He's actually the Federal Chief Technical Officer of Boundless, and he's going to tell us about Boundless. It's one of the big companies, big players in the open source GIS. We just finished, actually, they are in the middle, actually, right now running a big national conference in North Carolina, but thankfully, Anthony and Ahmed decided to come and visit us here, so we appreciate that. So Anthony actually has more than 12 years of experience as a lead solution engineer and solution architect with GIS for the defense and intelligence communities. He's also adjunct instructor for GIS in George Mason University in Virginia. He teaches courses in GIS theory and analysis. He has a Bachelor of Science in Geography with a focus of GIS from Penn State. And he's going to tell us more about his role as a CTO with Boundless and what he brings. So I'll leave the floor for you, Anthony, and enjoy the presentation.
All right, thank you. I have a few prepared notes. Can everybody hear me okay? All right. All right. Well, thank you, Tariq. I appreciate the kind words. I want to thank the Polis Center for the invitation to speak today. I'm honored to be here, share some thoughts about trends within the open source geospatial software world. My goal is to provide you with some insight into how organizations are leveraging hybrid architectures of both proprietary and open source GIS software, and then hopefully generate some discussion afterwards. For those of you that do not know me, again, my name is Anthony Calamito, Federal CTO of Boundless. I've spent the last decade or so focusing on ways the U.S. federal government can apply geography to all of their mission spaces, whether that be the Department of Transportation, emergency management, the DoD, military side of the house. In that time, I've witnessed many changes, both in the technology and the world that we apply it to. And as you might imagine, the increased use of open source software represents the next significant shift, at least in my opinion, in the way we're all beginning to do business. The open source movement actually dates back to the mid-1970s, mid to late 70s. It didn't really pick up steam until about 1985 when a man named Richard Stallman published his GNU Manifesto. For those IT folks in the room, you're probably familiar with this story. He's outlined this manifesto to talk about his desire to create essentially a free operating system that would be compatible with Unix. Shortly thereafter, in about 1991, a Finnish student named Linus Torvalds took the tools from the GNU project to develop what we now know as the freely available operating system Linux. Linux today is probably the most widely used server operating system in the entire world. And of course, it didn't take long for open source to grow beyond just operating systems and push it to other areas of IT, such as video editing, media sharing, and certainly into GIS. Sometimes called free and open source software for geospatial, or FOSS4G as it's most commonly known, open source geospatial software has grown significantly in the last 5 years. The federal government, with whom I spend most of my time, is certainly no stranger to open source software. The U.S. Department of the Interior, specifically Fish and Wildlife Service, launched the Map Overlay and Statistical System, or MOS, in 1978. The Army Corps of Engineers released GRASS in 1982 as the earliest open source GIS that supported both raster and vector data. Since then, other projects such as GeoTools, GDAL and Ogre, PostGIS, GeoServer, QGIS, GeoNode, and of course our platform, the OpenGeo Suite, have all come along and have been released. There are, of course, many others. But clearly there is a strong and robust pedigree of open source solutions in the geospatial community, each with a growing number of users and contributors behind it. The Department of Defense had debated installing open source software in its environment for years, hoping to reduce their dependency on high-cost proprietary software solutions. But many feared that the source code could not be trusted, and that support for bug fixes was limited to emails and community forums, and they just didn't want to take that chance. So in 2009, the DoD CIO sent out a memorandum stating that open source software could be installed on operational government systems, provided that it had a proper plan for commercial support and maintenance. This memorandum cleared any ambiguity around the support mechanism for open source inside the DoD, and has paved the way for other federal, state, and local government systems as well. As the name implies, open software has its source code freely and openly available to anyone on the public internet. This means communities of people from all over the world can see the source code, discover and mitigate any bugs they happen to find, and enhance the code base to include additional functionality over time. Many times, developers will self-organize in a location to focus on a portion of code or enhancement. These get-togethers, known as code sprints, offer a chance for contributors to meet in person and collaborate on the best path forward for the software. But this is not the wild, wild west. Just because anyone can contribute code to a project does not mean that all contributed code is accepted. There are gatekeepers, known as core committers and steering committee members, who manage what code actually does make it into the finished product. This series of checks and balances keeps the software self-governing and ensures that the code is always stable and ready for release. Much like Wikipedia, if someone were to contribute bad code, another developer would come in behind and quickly correct that moving forward. The same logic helps to dispel one of the biggest myths about open source software, namely that it is full of malware and bugs. And this is simply not true. From a security standpoint, open source software is typically more secure than proprietary software. I know that's sort of a mind shift for some folks, but Linus Torvalds, there's something called the Linux law, named after Linus, that states given enough eyeballs, all bugs are shallow. In other words, the more people who can see and test a set of code, the less likely or more likely that any flaws would be caught and fixed before that software goes out into the mainstream. This is very different than the security through obscurity model used in most proprietary software vendors. An open source developer is only as good as the code he or she writes. And so anyone writing malware or bad bugs into a software project would be outed as a bad developer, and their code contributions would never again be accepted into a project. So in many ways, open source code contribution is self-governing. Several open source software foundations have been created to help incubate smaller projects into mature technologies. In addition to providing developer resources, These software foundations also cover the costs of IP and legal review, ensuring that all code falls within the boundaries of the various open source licenses that they're produced under. The foundations also provide a certain level of credibility to a project. In the same way we all feel comfortable purchasing goods through a known reseller like Amazon.com, so too do organizations feel comfortable integrating open source software incubated through a foundation like Location Tech, OSGeo, or the Apache Foundation. For those of you that haven't seen it, Gartner published a hype curve back in 2010, which attempts to illustrate the phases technology steps through over time. There's the initial hype when a technology is first released, marked by initial funding and mass media coverage. This excitement usually culminates in what Gartner calls a peak of inflated expectations. However, slow integration efforts, initial failures, and sometimes even negative press around underachievement lead the technology to slide into what they call a trough of disillusionment. But then something magic starts to happen. The technology sees second and third generation releases, and more realistic expectations lead to follow-on funding rounds. Best practices are discovered, successful implementations are documented, and the technology begins to move steadily into what they call a slope of enlightenment. And this is where I believe open source geospatial software stands today. More robust next generation capabilities build upon initial efforts, creating more stable, more user-friendly software targeted at a more mainstream user base. Despite hitting the scene over about 20 years ago, it's only in the last 5 that our community has produced technology that is truly usable by the masses. And I would argue that we still have another 3 to 5 years to go before we realize the true potential of open source geospatial software in mainstream. And the best part is you no longer have to be a developer to use open source GIS. Instead of Linux-only installs with command-line interfaces, we now have cross-platform solutions, streamlined for minimal install footprints, and with a much improved user experience. Easy-to-use user interfaces are continually critiqued and enhanced, and additional analytical tools are contributed by communities from all over the globe. We now have polished, ready-to-use applications with low barriers to entry for common GIS users. There are many benefits to using open source geospatial software. But the easiest one to explain is the 80-20 rule. That is, 80% of users only use about 20% of a software's total functionality and capability. Plotting dots on a map, exporting simple overlays as JPEGs, digitizing vector content for imagery, or simple analysis such as point polygon filtering. Of course, there's still the 20% who do perform more in-depth, more analytical, deeper analytical functions, your power users, if you will, but by far they are the minority. So you have to ask yourself, is it worth spending all that money for proprietary software if you really aren't utilizing its full potential? Is there not a better option for the majority of your users who wish to simply geo-enable their workflows? Put another way, why are you paying for the Ferrari when really all you need is the Vespa? But most interestingly, open source software provides organizations the ability to scale without penalty. Licensing software based on number of instances, users, or cores is both risky and unsustainable as organizations move into more elastic cloud environments. With a proprietary model, if you need to do some unexpected increase in the number of instances due to some unforeseen event, you're charged with each additional license, right? You get a bill at the end of the day. But without licenses, open source software lets you scale as much as needed without worrying about costs now or in the future. Open source GIS is following overall trends in IT, namely the push from a legacy client-server environment to a more modern, what we call DevOps approach. And with it comes open source GIS solutions ready to play in a DevOps world. For example, for the IT folks in the room, you'll know what these things are, deploying 10,000 GeoServer instances in a microservice set using Chef and Ansible and Puppet, these automation and provisioning tools that are typically common in the DevOps world. There's a move away from legacy into this more emerging IT architecture. What's funny is open source GIS works on more than just Windows. It's designed for elastic environments in the cloud, whereas containers in a PaaS, like platform as a service. It can be scripted, as I mentioned before, using Ansible or Chef, quick deployment and scalability. It's a far cry from the proprietary vendors who mainly focus on executable installers on the Windows operating system. The outcome of all these innovations is a better ability to be flexible and to adjust to customer needs. Gone are the days of year-long development cycles costing hundreds of thousands of dollars or more, only to find out that advancements in technology have rendered your initial design obsolete. Now, 2-week sprint cycles allow you to develop a potential solution and test its viability almost immediately. You can then make necessary adjustments or decide to scrap your approach without having wasted precious time or money. Effectively, with this more modern DevOps architecture, you can fail fast, make adjustments, and move forward in relatively short time. No organization can be expected to rip and replace their existing architectures to a fully open source one, nor would anyone worth their weight in gold recommend doing so. So the community is beginning to cultivate a new breed of GIS that we call a hybrid GIS. This is essentially building a platform based on both proprietary and open source tools. It's not an or, it's an and. This is essentially, this can help an organization reduce risk and add value by avoiding any single vendor lock-in, reducing costs typically associated with licensing, and promoting interoperability with the existing software and architecture. It's important to understand that open source GIS integrates seamlessly alongside your existing proprietary software. Hybrid architectures allow you to migrate portions of your enterprise over time so as not to rip and replace the whole thing at once. And since open software is built upon the use of standards, you naturally build in interoperability the more you migrate away from proprietary. For example, you might have ArcGIS desktop users pulling from PostGIS, or QGIS users who access their base maps from ArcGIS server. Regardless of how you go, the hybrid model allows you to migrate your enterprise gradually to minimize disruptions to your overall operational mission. For many organizations, migrating the database first tends to be the easiest. This is because you're replacing a high-priced database with an open source one. You typically see a great cost savings almost immediately. Those back-end proprietary databases are pretty expensive. And since your end users are still using the same client they're accustomed to every day when they come into work, the change is almost invisible to your end users. Integrating open source application server level recognizes further savings while injecting interoperability into your architecture. GeoServer, for example, allows you to publish your spatial data in any of the Open Geospatial Consortium or OGC standard formats. The use of standards means a service published once can then be consumed in any number of proprietary or open source end user applications. And finally, migration focused at the user interface tier allows you to leverage the power of that 80-20 rule I told you about earlier. The geo-enabled users that make up your majority 80% can most likely leverage robust open source applications like QGIS. You can even consider migrating capabilities to purpose-built web applications to further lessen the dependency on costly desktop software. And the remaining 20%, this opens up your budget to support that remaining set of users who require that edge case functionality found only in proprietary software. So you get to use both. But don't mistake open source software as being less capable than its proprietary brother. In fact, oftentimes the opposite is true. For example, support for geospatial big data visualization and analysis is being spearheaded in the open world through projects like GeoMesa and GeoTrellis. These projects aim to enable large-scale processing of data at rest inside of Cumulo, HBase, Google Bigtable, and even Cassandra. But this support extends to big data streams as well, utilizing the power of Apache Kafka and Spark to visualize and analyze data as it flows in from sensors in real time. This enables open source technology to support industries such as precision agriculture, connected cars, and even wearable technology. Balance even has customers who are building out Lambda architecture supporting batch, speed, and serving tiers all at the same time. We're beginning to see municipal governments explore support for smart cities. Cities and their governments who have maximized data collection, data mining, and data-driven analytics for the betterment of their constituents. Forbes magazine believes smart city is a term that we're going to be hearing a lot more of in the coming years. It's thought that by 2020, we'll be spending about $400 billion a year building them. The premise of smart cities suggests that rather than looking at a city as a set of independent functions, the water and sewer system, the electric grid, the transportation network, for example, we should consider looking at them holistically as a central nervous system which feeds, interacts, and adjusts itself in real time. And open source geospatial software like GeoServer, GeoMesa, and GeoNode, which we'll hear about in a little bit, can provide you with a license-free way to support your new smart city initiatives. Boundless spun out of OpenGeo back in 2013 as the world's leader in open source geospatial software. We've commercialized our flagship product, OpenGeo Suite, as a complete geospatial platform. This package enables organizations to reliably manage and publish geospatial data across web browsers, desktop, and mobile devices. The suite includes 6 open source geospatial products. PostGIS, which is a spatial database extender for the open source Postgres database. GeoServer, an application server for sharing data as web services. GeoWebCache, a Java web application used to create tile cache, the same tile cache you're used to seeing in Apple Maps and Google Maps, fast loading cache. QGIS, a free and open source desktop GIS, very much akin to your ArcMap. OpenLayers, a feature-packed library for all your web map application needs. It's written in JavaScript. And GeoNode, a geospatial content management system, a portal, if you will, for the search, discovery, and collaboration of spatial data. The enterprise version of Suite also provides additional software components that Boundless has developed, including a myriad of plugins for GeoServer and QGIS, which extend their out-of-the-box capabilities. But Boundless provides more than just great software. There's also a full complement of technical support, maintenance, training, and professional services to ensure the success of the implementation of open source. This support and maintenance is the type of insurance policy organizations need to run open source solutions in an operational environment, and represents the commercial support in the aforementioned DoD-CIO memorandum. But most importantly, the Boundless team has deep GIS and open source expertise and in-depth knowledge of the industries that these GIS applications are being applied to. We employ many of the core contributors and steering committee members of the community open source projects underneath the OpenGeo Suite umbrella. Working with Boundless gives our customers unique access to those developers and to the open source communities that they support. Many state and local governments throughout the U.S. have already published their geospatial data publicly to open online portals. A great example of this is my hometown of Raleigh, North Carolina, who hosts all of their geospatial data freely and openly for all to use. Another great example is the OK Maps Clearinghouse, developed by the state of Oklahoma. Built entirely on open source software, OK Maps publishes the state's data via open standards for maximum operability, both in and outside of the state. Boston's Office of New Urban Mechanics released an app called Adopt a Hydrant. The program contains a map of all of the 13,000 fire hydrants located in the city and lets residents pledge to shovel out one or more during a blizzard event. And in a city with an aging infrastructure like Boston, this app allows residents to share mutual responsibility for fire safety with their neighbor. More important than getting a valuable service from its citizens, while cutting costs and saving taxpayer dollars, the citizens themselves have a sense of pride in giving back to all who live in their communities. Similarly, Portland, Oregon released an application for residents to report infrastructure issues throughout the city that they call PDX Reporter. And finally, open source software has become critically important to disaster relief efforts. GeoNode is often deployed immediately after a crisis as a portal to collaborate on relief efforts. Since there are no licenses to keep track of, you are free to provide GeoNode to as many users as needed. You can even share with other nation states, nonprofit organizations, and emergency responders without worrying about breaching any license agreements. My colleague, Ahmed, will come up here, take the podium shortly to talk more about GeoNode, so I won't steal any more of his thunder. But before he does, I wanted to leave you with a quote from Mahatma Gandhi, as I think it epitomizes the way in which people have thought about open source for the last few years. What at one time was just a niche hobby for some trick developers has turned into a serious movement with a tremendous amount of potential behind it. Those who laughed it off in the past as merely a passing fad are certainly taking it a lot more seriously now. So I encourage all of you to think open and evaluate ways to incorporate open source technology into your existing workflows and architectures. The technology is only going to get stronger, and the possibilities are truly boundless. Thank you.
So we have like a few minutes. We can entertain. I think I have to have the mic because of this. We can entertain some questions to Anthony, and then Ahmed will follow with the presentation, like 5 or minutes, and then Ahmed will gonna follow with his presentation, and then we can have open discussion after that as time permits.
Sure.
So, any questions?
It's on. Okay. Hello. My name is Rudy Banerjee. I'm an associate professor at GIS at UPY, and I had a comment on this presentation. It's really good. But one of the examples I try to show in favor of open source is R software for statistics. Now, if you know the history of statistical software, it's all SAS people used to use, and there was an article around in 2008 in New York Times where some reporter actually was coaxed by the SAS people, and SAS is the best company to work for many years, they've said. So it's a great place to work and on. But their software would be the choice of software for Fortune companies and everything. They wrote an article why R is not going to make it, because SAS provides them with security and everything. Now, 5 years later, there was an article in New York Times, and there's an article saying that SAS is going to support R and R platforms, because SAS is actually losing against R. And I hope that happens with every closed source software.
No comment. Yeah, that's a great point. I don't know that there's any talk of Esri supporting Boundless or Boundless supporting Esri, but I can tell you for sure, we're being asked to do these hybrid implementations, as I showed you up on the screen. You will see very shortly direct interoperability between the two platforms. And by that I mean add-ins to the ARC GIS platform, which enable work with the open source side, as well as our side of the house, building capabilities to push back to the Esri side of the house. And that's not driven by either Esri or Boundless. It's actually driven by the community. And by the community, I mean both the users and the developers of the open source projects. So I think it's inevitable that interoperability between the two systems is going to happen whether we want it to or not. The community is just going to make it happen. So.
Thank you so much, Anthony. So we are going to actually open the discussion, the floor for discussion after that.
Thanks for Anthony for giving us a big picture about what's open source software and the trends, and a little bit of some claims about the relation to big data analysis and GIS. The second speaker is Mr. Ahmed Osman, and he's going to actually give us some live demo to see how things are done in practice with some examples for different cities. I don't have to read from paper because I know Ahmed since 1994. At the time we both had hair, and it was black, so I know him for over 23 years different, almost. And Ahmed has a very long history in GIS. He's one of actually the pioneers. I know him at the time in Egypt. He was actually one of the few people really who talked about GIS back in the time. And for a while he worked with the Egyptian government, and then he went to Esri for over 10 plus years, and he worked in a lot of international projects where he led in Cyprus, in Indonesia. And around 10 years ago, he started his own company in the Middle East, and he's now a partner to Boundless. He's running lots of projects actually in Africa, in Middle East, in Emirates, and very talented geek. So he's going to actually show you some of the practical examples of how actually, the open source GIS has been used in different cities, and then we can open this for discussion. Ahmed, the mic is yours.
Thank you, Clark. And I would like to thank the Police Center for the wonderful opportunity in a great state. First time here. So this is going to be a live demo. And if everything goes right, it would be the first time for me that everything will go right in the live demo. If this happens, I will move to this state. So I had this presentation, the notes on what is JMO. JMO is I will take only the first few slides and then we move to the demo, and it's best to see the thing in action, right? Okay, GeoNode is a spatial data infrastructure framework, and this provides a basis for spatial data discovery, evaluation, applications for users and providers with all levels of government, commercial sector, non-profit sector, academia, and by citizens in general. Okay, so GeoNode was started in 2010, I believe, and it was an initiative by the Global Facility for disaster reduction and recovery and the United Nations, and it was implemented by Boundless when it started. And they needed something that installs very quickly and scales very fast and allows multiple organizations to work together on the same data. So this is the idea that had GeoNode started. Basically, it's a CMS for GIS data. It's a hub to have you put all your GIS data, your documents, and your shapefiles, create maps, and interact with other users on the same content platform. And it is enterprise ready, meaning it is very scalable and very strong and could be deployed without problem. And all the underlying technologies are very robust. Okay? And the GeoNode is based on all open. So it provides open APIs. It is based on open standards, and it has components that serve open data, and it is designed for non-expert users, so it is very easy to work, and it actually rewards the collaboration, so you can, like the social engines, comment and do star rating, and this is to encourage the users to actually better provide metadata support. So if you find something that is not complete in the metadata, so you can comment and request more and so on. At the same time, it is also designed for the GIS experts, and because of its open APIs, you can consume APIs from your mobile application, and you can work with ArcGIS Desktop, you can work with QGIS, so it integrates all the known commercial softwares and the open source softwares, and provide a platform to have secured access to the served layers. And these are the main components of GeoNode. It has layers, maps, documents, groups, and apps. And GeoNode is basically a cluster of data, maps, and users, where in this cluster you have securities between the stacks, so you have the users can give access to other users to see data and maps, and all this is a platform integrated together. And the underlying technologies is GeoServer, and coming up is GeoGig, and this will be provided in the new Exchange platform, which is just released. And it has a very strong established community. The GeoServer is actually very strong. And on top of GeoServer, handling all the data management work and the authentication is Python and Django. These are, it's a Python framework, and it's also a huge framework, and it's all open source, and it has an incredible community. And on top of that is the Geo Explorer, also from Boundless. And this is the mapping application that is using all these underlying technologies to interact with the layers and the maps and allow you to author your. So I will stop here. I just want to, something is not covered.
Let's go live.
Yeah, before we go live, because this we will not see in the live presentation, is GeoNode provides federation, and that is something very strong. Meaning you can have multiple instances of GeoNode, and those instances will talk together on different levels, especially with the utilization of this new technology. exchange a GeoGig, you can allow two geonodes to work on the same data set in offline and disconnected mode, or not. So it is something we can set up now, and we can at the time of checking of the data, you can version it, and you can, if there's any, you can resolve any conflicts if this happens. And if there is no need for that, then two or more different geo nodes can search one another. So you can have layers in one, and it will be aware of the other, so you can apply your search across multiple geo nodes. The other thing is that the GeoNode can serve as a hub for a hybrid implementation. And if GeoNode sits in the center, it can be connected with your ArcGIS desktop. It will work perfectly. And at the same time, it will also work with QGIS. It can work with other geoservers. And you can use GeoNode to serve content even to ArcGIS.com. This is also possible. And of course, you can work with other GeoNodes. So with this setup, you have really a lot of freedom. There is no boundaries to what you can do because it works, it really fits well with all the components. Basically what it does, it puts a very strong security layer on top of GeoServer. And this is something that was really missing. So, and by putting this very strong security layer on top of GeoServer, you can access your data from anywhere because it is following the WMS standard, WMS, the OGC standard. And I think now we can start the demo. So here I have an instance of GeoNode. You see the components of GeoNodes are the layers, maps, documents, apps, people, and group. And the groups are basically groups of users. And when you cluster users in groups, you can allow access to certain maps and layers to the people. And what we are going to see here is we look at the layers. Layers are searchable. So if I type in NYC, you get all the, you will find that all the layers have categories, groups, owners, so you can search and you can describe layers with a number of things. And then you can upload your layers. So in that case, I'm going to have a layer already prepared here. And this is the NYC pedestrian fatality. Just drag it. And say upload. And then just go to the layer info. You can go and edit the metadata. We have very strong metadata editing tools. Okay. Doesn't seem I'm going to move to Indiana. Okay. So it is uploading, but the layers. Okay. So we look at the other layers. We have the bike fatality, for example. You start that, and you can change the symbology. So you do edit, and in the edit interface, you can edit metadata. And this is all metadata standard editing. You can edit the styles. So if you go there, and you can go here and change the symbology or the color or the size. So you just make it a smaller size and change the color. Red color. Okay. Just save, and it has already update it to the desired color on the fly. And then you can zoom in, zoom out, the standard GIS stuff, and then you can create a map. So you create a map with this layer, and then you can add more data here. So add layers, going to get some more NYC data here. Okay, so I want to see if it's out yearly. It's appropriate. Then add. Okay. And I go back to layers and I can reorder. Okay, I can reorder and change symbology again. And all I have to do now is just save the map. And I put this NYC. NYC fatalities. Save. Now is this is a map here, and it created the map. I can go to my map. I see the layers in my map here, and then I can change the permission on this map, allowing any group. So I had created a group called NYC staff. So this group of people will be, I can uncheck anyone, and then the NYC staff group will be the group having access to this map. Okay. And then you can also share the map. You can add ratings to the map if it's good or bad, and this is to encourage people to work on a map in a social way. You can add comments as well. And this will apply to the layers, the documents, and so on. Okay. With the documents, you can add, like any content management system, your PDF and your documents, your training material, but you can also add symbology. So here, if you want to put icons like the museum icon here, if you look at the layers, you will find that, I'm trying to find the museum there. Okay, so here this is the NYC Museum. I edit the layer, edit the style, and I can give a URL to the markers and it will take it from there. So we use all the components together to define our symbology. Okay. This is what you can do with the layers. The documents, of course, serve much more purpose. It's also searchable, so it works very well for documentation. Once you have all your data there, then you need to have some apps to drive, to drive this. So there is a number of apps you can work with. Notably, actually, is an app that will expose your data to the Esri feature service. So, for example, here, look at the bike fatality. I can see this as an ArcGIS feature service, REST API, and here are the same bike accidents. All this is actually coming from Jimbo, and it is displaying, it's playing very well with ArcGIS.com. So you can take your content from Jimbo and go to ArcGIS.com and even style it. You can look at the attributes. We can do queries. So let's see. Year is, let's put 2014. didn't work. Let's do it again. So you can do a lot with ArcGIS.com and with your data there. I think you can style it. So here it is, and then all the identify and query operations work there. And then you can save your map in ArcGIS.com and share it and publish it into Esri templates as well. What you can do is also a number of other apps. So you can view your app in, for example, a mapping viewer, which is another viewer also created by Boundless. So you say create new, and then you select the map you just created. You fill in all the configurations needed. And this is, I want to enable search, I want to show the legend, I want to show the layers. And so it's just configuring all the parameters you want for launching your app. And then you click save, launch. Now you would have a nice view of, remember, this was the map we just created, but we put it in the context of a web application. So we can have different web applications using this map as the basic configuration for the application. And here you have other, other capabilities in this mapping application that were not available in the Geo Explorer, for example, advanced filtering and heat maps and so on. Okay, there is more apps, for example, mobile workforce. So in the mobile workforce, you can, here we created an instance ready for the maintenance of the bike racks. So you launch, and here you will have an application that's showing the instances. Okay, just open up the instance, and the instance would be assigned to a feature. And so these are the bike racks, and you can assign a job to be performed on this bike. And this would apply for any geographic feature. So you can, if you have pipelines or street posts or whatever, you can keep applying jobs there. And of course, it follows all the standard job, resolve, close, duplicate, and then you have a map showing all your jobs, where you can create a new job. And when you create a new job, okay, you put all the job information there. And important is you just select the feature, and the feature which you will select will have this job assigned. Right here. Okay. So now I selected the feature, just say select, and the job would be assigned to this feature. So it is enabling work orders to be applied to geographic components. So all this is done within the GeoDjango platform, which is sitting on the GeoNode, within the same platform as GeoNode. So we do not have to go extend and write our application somewhere else and work with APIs and access the servers by APIs. It's all we can. GeoNode and GeoDjango have a huge community, and it's full of apps and APIs you can use to very quickly develop these types of applications. Okay. So, and these are just some more Esri apps, templates that use the Carto server to integrate the content from GeoNode into Esri, This is another app. It's the feature list app. It's just basically listing. So this is for the New York Museum launch. And just click, you get the information, or you click here, you get the information about the museum, or you can search the museum here. It will just provide you, a list of the features. For any app, after you have created the app, what you can do is you can also edit your app instance. So in your map viewer, if you explore, so we just created, we look at, for example, this instance here. We say edit instance, and in the instance we have the settings, so you can go at any time and change your configuration. Okay, so I think this covers some part of GeoNode. What is also important to note is that if anybody is familiar with the GeoServer part of the GeoServer is still there. This is GeoServer. We just have all our layers sitting here, and these layers are accessible to ArcGIS Desktop and QGIS via username and password through GeoNode, because the user will upload his layer there, set the username and password, and when this happens, he will go to QGIS and access the information the same way. So I think that's the overview for GeoNode for questions.
Thank you. Do you have any questions for Ahmed?
I'm looking at you, Jim. Those probably have thoughts, right?
Sure, yeah, because you got the wheels turning.
Okay.
Sure. I'm Jim Sparks, Indiana Geographic Information Officer, and the Internet of Things in particular is exciting to think about, especially from a governing perspective, and recognizing that we all want to pay fewer dollars in taxes and we want more services at the same time. And I think Internet of Things might be one of several answers to how both of those things can happen at the same time. For example, when I think about something like trash pickup, City of Indianapolis is a wonderful place to be, both as a citizen and also as a visitor. And one of the things I like about Indianapolis is it's a very clean city. So to help Indianapolis stay clean, we have lots of trash cans all over the city, ready for you to put your wrappers in there, cups and whatever else. But do we really need people to dump a half-empty trash can or an empty trash can? Probably not. How about if we had an Internet of Things sensor on that trash can that said, I'm empty, or I'm half full, or I am full, please pick me up. So that dedicated resources could be more specific about how they're engaged and used, and go to where the need is instead of treating everything the same. It's a very small example, but you take an idea like that and you extrapolate, expand out, and it's exciting to think about what we could be heading towards with this. And by the way, that is a spatial issue, right?
Yes, it is.
Tarek, I've got just a little comment to play off of. It has nothing to do with open source conversation, but just with the election, something I noticed. So we recently just had the primaries, and something that came to my attention is I'm in Marion County, and it's big enough that we have different locations of, is it precincts? Is that what they're called? Like the location, and then within that, I get there, and I did my research, I figured out where I needed to go, and I get to the location, and they go, what number are you? I have no idea. I looked myself online, and there was no number telling me where to go. So I had to go to a map, and they said, well, it's not busy, just stop at all 4 tables. Well, that's not really, I'm not gonna do that. So I looked at the map, and I'm going, okay, I'm -6. What does that mean? That didn't mean anything. Even if I looked online and it said -6, I'm not gonna remember -6. So what is it we could be doing to figure out how to connect? Maybe it's what sticks with people's mind. Like, is that an animal or something? You get there and you go, I'm a llama. Okay, I go to the llama table, I remember that. Or another issue, like Johnson County, you guys had long lines. Maybe there's, you guys don't have the separation of things, but maybe there's an app that you go to and you see how busy locations are. So I just think while we think we're all there all the time, I think, like Marion County, why we didn't have that extra step to help people once they actually got to the location. So just kind of a brainstorm idea, a complaint.
I was going to say, that's sort of the beauty of the open source model, right? Is if you want to build something, build it. Mm-hmm. Like, there's nobody stopping you. And that's not a knock on proprietary software. It's just, that's what's really interesting about the open source movement is if there's something that's needed, you can actually go and build that and contribute that towards the code base, which is really exciting. A lot of times with bigger software companies, if that thing doesn't help their bottom line or they can't apply it to more than one customer, it sometimes gets pushed down the roadmap. And I think that's a perfect example of the epitome of the open source movement. There's something I want to do, so I'm going to do it, and then I'm going to contribute it back. And then the community will determine whether or not that's something that's useful or not, and either integrate it into the next release or maybe not. Maybe it's an extension that they have out there, and people can download it if they want it, but it's not necessarily part of the core software. So it's a great example, and I really think that's one of the exciting parts about the open source movement, is it gives you that option to build it in there.
How is the open source, can you even call it an industry? I guess I'm having a bit of a hard time understanding how it exists within our economy. I mean, when people are driven to make these improvements that you're talking about, which is amazing, but how far can it actually go without the incentive of profit, for example?
I don't know that it's profit necessarily that's driving it. I think that's the whole point. And business is driven by profit. I think the open source community, and that's really what the term is, it's a community, whether it be just the geospatial open source community or the open source community at large. If you go back to, Richard Stallman, you go back to Linus Torvalds, these are people who just, in their heart of hearts, really wanted to make something that people could benefit from. It wasn't a business drive. They didn't set out to make multi-million-dollar companies. They set out to give back something to the people, something that was useful and beneficial. And so I think really at its core, that is one of the fundamental differences, is it's not a business-driven model as much as it's a community participation-driven model. Now, will some companies make revenue in the process? Sure. There's plenty of space for doing on-site services work. There's certainly a business behind the support and maintenance of open source software. There's certainly a business behind, folks that sit side saddle to you and your organization and make sure that the machine is running, right? That the base maps are being served. And so I think there is money to be made, but I don't think that's the driving factor of why people are moving to open source. I think that's the big distinction. I don't know, did you want to add to that at all?
The open source, it has a, because you're saying how can companies really sustain their existence if everything is free, right? It's a different business model, really. I mean, it's not, we're working with open source, helping the community on one end, but providing services for other businesses and governments on the other end. So from one side we are doing community work and we are bettering the software. And the bigger difference here is that if I am a proprietary house, I would you ask me to do a job, I will do it, I will roll it in my software package and I will sell it and sell it and sell it and sell it and make profit again. In open source it's different. You will pay me to do the job, I will take the software, I will get paid, but then everybody else will benefit. And this is probably, we are making money as open source, for sure, and this is how we make by providing the service, but I think the real difference is we do it once, we do it right, we give it for everybody else to use, and it grows this way.
Any other questions?
Yes, I was wondering if you have any clients on the public safety side or the healthcare side yet?
Both of us?
Yes.
We do. We have several clients on the Homeland Security disaster response side of things, and GeoNode is probably the biggest example of the technology being used in that case. Everything from Department of State to Red Cross to Department of Interior, the state of Louisiana. Now their whole Department of Health and Human Services now all based on GeoNode. So absolutely, we have many examples of both federal and state customers using the open source technology to do that type of disaster relief, humanitarian aid, humanitarian assistance type of work.
Okay.
All right, I'd like to thank Anthony. We're going to end it right now. Anybody else? Okay, we're going to end it. No? Yes? Okay, we're not going to end the presentation right now. I'd like to thank one more time, I'd like to thank Anthony and Ahmed for their presentation.